Welcome students. Today we will start the basic concept of laws of motion. Newton's laws of motion, first law, second law, third law, we know all these things. From second law, that is the rate of change of momentum is nothing but force and acts along the direction of the change of the force. Momentum. I am not going to tell about that part. From that formula we derived F equal to ma. F is applied force, m is mass, a is acceleration of the body. Here in class 9 we covered if force is acting like this, mass is m, then it will be equal to, if it is moving at an acceleration a, then F is ma. It is only x-axis. So any three-dimensional motions can be resolved into three components. D'Alembert's principle I am going to tell you today. What he told, that net force acting along x-axis, how he wrote, summation. This symbol is what? Summation of fx. Suppose f1x plus f2x plus f3x plus f4x, like that, is equal to mass of the body, acceleration along x-axis. Similarly, summation of fy, he told it is nothing but may, acceleration along y-axis. Summation of fz is nothing but equal to maz. For example, I am writing here a body. Suppose this is F1 force, this is F2 force. That means here acceleration will be there along which axis? Only x-axis. That means I will get ax exists, ay is not there, az is also not there. So what is summation of who will exist? Fy will 0, Fz will 0, because Ay, Az is 0. Only x component exists. If body mass is m, then I will write summation of Fx means F1 plus F2 in vector is nothing but equal to, or I can write in summations also, max. Today we will apply this concept. But before that, we need to know what is free body diagram. What do you mean by free? Suppose a body is situated on the ground. This is the ground symbol. Whose mass is m. So who is acting downward, who is acting upward, who can tell? Always we have to focus from center. I will tell, yes, you are right, whatever you are thinking. Body weight is acting downward, mg, or that is nothing but weight. So if I remove this ground, what will happen? It will fall down. So how it was in stationary position? There was an invisible force which was acting upward direction. So that upward direction, from ground to the body, I am writing here normal. So what is the free body diagram of this body? I will draw like this, remove that support. So who is acting here? If I will draw it properly, I will get two forces. What is that force? One is mg, another one is the normal force. Always normal force is acting from the ground to the body perpendicularly. Again I am telling, from ground to the body perpendicularly. That's why its name is normal force. Can we apply D'Alembert's principle here? This is for which axis? X-axis, y-axis or z-axis? Yes, you are right. This is y-axis. That means I will write what? Summation of Fy equal to may. Body is in motion or rest? Rest. Rest means what should I write? Rest means acceleration along y-axis is 0. Now, body is in rest means that is okay, but what are you getting here? One is upward, one is downward. Yes, Cartesian coordinate system you apply. Upward means plus, downward means minus, left side means minus, right side means plus. That concept will apply. So I will write N is plus, mg is minus, resultant force is 0 because MAY is 0. So here what I got, N equal to mg. That means here normal reaction is m into g. After this class, I will give you some task, you have to solve it. Now, if I think for two body system, here is two body, let this is the first body, let this is second body, but combinedly it is one system. Let its mass is m1, let its mass is m2. How many forces are there? Let me remind you, in free body, only external force is considered, not internal force. Again, let me tell you, in free body, only external force will act. Okay, we'll see it later. Who is acting, which direction, let us see. So from here, I think one force is acting. Who is that? Normal N1. And from center, who is acting downward? M1G. Similarly, if I draw another force is acting downward due to M2, so I will write here M2G. Now, this is also a joint. This body is also resting on this body. Just think that Namaskar posture. In this Namaskar posture, one hand is applied force, another hand is also palm is applied force. That's why normal reaction to both directions are also there in opposite directions. Similarly, in this case, another normal is acting from 2 to 1. Action and reactions are equal. So from here also, another reaction is there from 1 to 2. Again, there will be confusion, I know. Let us see it again. At this joint section, from 2 to 1, one normal reaction is acting downward. Again, from 1 to 2, another normal reaction is acting upward direction. Is it clear now? Let us draw three free body diagrams due to system, due to 1, due to 2. So I am writing now, let free body diagram for system. That means, if I take this system, these two forces and two downward and upward are internal forces. Like a person is standing here, the lower person and this is the upper person. For a person from waist to chest, if I divide the person into two parts, then you will see one force is also acting the upper half of the body, applying force to downward also applying force to upward. But when I am considering the total main, that internal force is cancelled. Similarly here, you just think that for the system, N2 is internal force. So it will not consider. So who will be considered? Two things will be there. This is the system I have to consider. For this system, who are the forces? Let us check it. I am getting, this is N1 is acting externally, upward direction. M1 and M2, the weight due to M1 and M2 are also acting downward. So what I am getting? M1G. Another force is there, M2G. So similarly, if I apply which formula? Summation of Fy equal to MAY. Due to rest, AY is equal to 0. So I will write here N1 minus M1G minus M2G equal to 0, or I will solve here I'm just writing that n1 equal to m1 plus m2 times g. Let us go for free body diagram for body 1. For body 1 means this person. If I draw for that body only, this is the body 1, mass is m1. Who are the external forces? n1 is also externally applied, n2 is also externally applied, and due to m1, only m1g is acting. Due to m2, m2g is separate thing. So who are the forces? If you will check it properly, I will tell you that those forces are, so due to m1, m1g, n1 is from the ground, n2 is from second body. That means this is also external. So similarly, if I apply Fy equal to MAy, I will get n1 minus m2 minus m1 equal to 0. So I will write it here, n1 minus m2 minus m1g equal to 0, or I will write n1 equal to n2 plus m1g. Let us go for the free body diagram for 2. In this case, what happens? If I draw for 2 case only, I am getting due to m2, m2g is acting downward, and I got one external force, that is from m1 to m2, that is n2. So from here I will get n2 equal to m2g. I hope you got that idea. If you did not get it, you can repeat this video again. Let's go for the new concept, tension and compression. Let this is a pen. I want to stretch it. So what are you getting? If I stretch it, external force is acting outward direction. This tensile force is known as tension. And when I want to compress it, so external forces are acting into the body. So this is known as compression. In tension, what is happening? There is a normal force. For this external force, one reaction is there inside. For this person, one reaction is there inward. That means I am telling there is a force inward. Let us make it F prime or small f. So for tension, tensile force will act inward direction. Similarly, when I want to compress, what will happen? The reaction is acting outward direction, compressive force. Let us apply to a pulley problem. Let us think it here. Of course, here I have drawn for 2 body case. Let us draw for a single body first. Suppose there is a rope and the body of mass 10 kg is there. What is the tension? What is the weight? How can I know what is the tension acting on the rope? For this body, weight is acting downward. For this case, tension is acting like this. So these forces can be represented as T. These forces can be represented as C. Now my question is, if I will take this person, so what I am getting? T equal to mg, or T minus mg equal to m into a, but a is 0 because body is rest. So what can I write? T minus mg equal to 0, or T equal to mg. I got tension. So what is the tension now? Suppose G is 10, mass is 10, I got, this is nothing but 100 Newton. I think it is clear. Let us go for a pulley problem. Here, by the help of a massless rope, you can consider two masses are there, M1 and M2. What are you thinking? Body will be stationary or it will move? Whatever you are thinking, just express. Of course, it will move. In which direction? In which direction? Mass is more. That direction. This direction. That means it will acceleration direction will be downward. For this, acceleration direction will be upward. It will move down. It will move up. Let us go for that. So obviously this is, let it is M2, so it will be M2G. Obviously this will be same tension because it is same rope, same tension, and who is acting here? Let it is M1. So what will happen? M1G. Where is the acceleration for this case? My mistake, acceleration will be upward, and this case acceleration will be downward. This body is moving upward, that's why I took acceleration upward direction. Let us go for it. Since body is moving upward direction, since body is moving downward direction, I will get two free body diagrams. Now, what are those free body diagrams? Let us consider. First, let me write for the first body. Let this is M1 first body. So I am writing here free body diagram for 1. Now look it here carefully. Let us draw for free body diagram for 1. What I am getting here? Who is acting downward? M2G. This is for body 1. Who is acting upward? Tension. What is the direction of acceleration? Body is moving downward. Shall we start now? Let us apply. This is y-axis. Summation of Fy equal to My. So what is Fy? Let us consider it here. T is plus, M2G is minus, equal to My. This is for, sorry, my mistake. This is 1. So obviously this will be 1. So this is M1A. But I have to write here minus because body is moving downward. Consider it. You have to focus here. Why I wrote minus? Because body is moving downward. That means T minus, this is 10 into 10 is 100 equal to minus 10A. Let us box it equation 1. Similarly, let us go for the second part. What is the second part? Free body diagram for 2. So what is happening in 2 case? Look it here and let us write it here. So if I will draw free body diagram, to downward M1G is acting, to upward T is acting, body is moving upward direction. Let us focus to this situation now. Now if I will solve it, what will I get? Similarly, what will I write? Summation of Fy equal to M2Y. So who are the forces? T is plus. This is downward means M1G minus. Upward means M1A. So I got T minus, what is the mass I have written here? Let us check it. 5G. G means 10. Suppose I took it, equal to 5A. Let us mark it equation 2. So what is equation 1? T minus 100 is minus 10A. Let us write down. T minus 100 equal to minus 10A. Now you know how to solve it. Either I can eliminate T or I can eliminate A. Let us subtract it. So T will cancel. So this will be 50 equal to 15a. So I will get a is 50 by 15 meter per second square. And if I'll put that value of a either in equation 1 or equation 2, I will get t. So I will write it t equal to 100 minus 10a, that is 50 by 15. After solving, I will get t. I think it is clear. You have to solve it. My problem is like this, lots of problem we have to solve. Let us go for the last free body diagram case for today's concept. Let us focus it here. For these types of case, this is a slope. Body is just rest in that situation. Suppose it is sufficient to be in rest. How to draw the free body diagram? If body is in rest, I have to think the gravity first, which is always acting perpendicularly to the ground. This is my weight or mg. Another thing is coming to mind. What is it? Who is acting normally upward direction? From the ground, always this is the ground. It is perpendicular, so this is my normal. So now, how to solve it? Suppose body is in rest. Next question I will give you how to solve it. If it is in rest, we have to focus. This is her. This is one is perpendicular, one is like this, so it is very difficult to do it. Either you can take this as y-axis, this as x-axis, or you can take parallel to the ground is x-axis, perpendicular to the ground is y-axis. I will tell this concept. Parallel to the ground is x-axis, perpendicular to the ground is y-axis, which is represented here. Let us look to this figure. From this triangle, let us name it A, B, C, let it is D. Let it is E. ADE, this is 90. This is theta. So obviously it is 90 minus theta. Now look to this triangle. Let it is OEF triangle.